Okay, thank you. Hello, everyone. Thanks for attending this session today. My name is Zhuo Wu. I'm an AI software evangelist at Intel. I'm very happy today for presenting this topic. So today, we will talk about some pains in the computer vision community and how we can break those bottlenecks using Intel products. Well, here you can see this is our team of evangelists. And you can see we are based in different corners around the world, and we are actually a worldwide team working for developers like you. So let me first introduce myself. My name is Zhuo Wu. I'm an AI evangelist, and I have been working for more than 15 years trying to bring the gap between technology and users. If you're interested to know more about my work, please connect with me in LinkedIn. And please stay tuned until the end of the presentation. We will have some prizes for you. Okay, now let's start. So first, let's take a look at some challenges. As a developer in computer vision, I've been facing quite some challenges. And I could say that one of the biggest problem is the data. So trying to imagine that before you try to build or optimize and deploy your CV model, the critical thing we need to do is to find or create a good data set. A good data set is expensive, and not all the time we can catch the same number of images for each class. So I would say that data is a cornerstone of the majority of computer vision models. So what happens if we don't have enough right data? How can we build, optimize, and deploy a good CV model in this case? And so maybe that original problem will create more problems in accuracy, performance, and also optimization and deployment to affect the behavior of the production system. And so data is important because data is the key for helping AI systems to learn effectively. And bad data could affect the performance of your model, and it could result in frustration for you. And also, this is a common problem in the industry. So for example, Eigen Innovations is also facing this imbalanced data set situation with not enough samples of defect data. They're helping manufacturers to prevent quality issues. And so they're using Intel solutions in order to be more efficient in the production system and detect defects with less bias. And this challenge, it is not just for Eigen, it is a common challenge. The nature of the real-world scenarios in manufacturing is to have an imbalanced data set. And how can we work with factory data that doesn't include enough defect samples to train an accurate model? We can see normally we will have many good samples, but not the same number of defect samples. So what we do and how can we fix that? Okay. So the nature of this situation, of this real-world data sets, motivated the creation of anomaly. But what is anomaly? So anomaly is a library for unsupervised anomaly detection from data collection to deployment. With this library, we don't need defect data and not much normal data for training. And here, I invite you to visit our GitHub repository. So please scan this QR code to access the repo. In my perspective, it is a great library, well documented, and it has been received pretty well by the computer vision community. We have around 42,000 downloads per month and more than 1,500 stars. And for me, I have used Anomaly in my projects. And for that reason, I'm very excited today to share this with you. I really love this library. And you can see here in one of our projects, actually we did a tutorial in CVPR last year. We're trying to looking for a simple way to build, optimize, and deploy a model to check cubes in the production line. So we simulated the defects on the cubes. As you can see, cubes with nothing on it stand for the normal cubes, normal pieces, but the cubes with the sticker on it stand for the defects with the cubes. And so we follow the instructions in this anomaly repository, and all those things could get the demo working, and it could work in this way. And you can take a look in this video we made for this demo. To hack the robot was another story, but it is working pretty well. And so here you can see how the robot will keep the piece in front of the camera, and anomaly will work on the background to detect if this cube is a normal piece or abnormal piece. If it is normal, it could be put into the production line for the next manufacturing process. If not, it will be select out and will not be put into normal production manufacturing process. So this is how anomaly could help us very effectively on the anomaly detection on the production line. And next, let me explain to you how anomaly is working. So as I mentioned before, anomaly is a library for unsupervised anomaly detection from data collection to deployment. And anomaly actually can support different kinds of computer vision tasks. And we have those options such as segmentation, detection, classification, and also abnormal event detection. All those CV tasks could be supported by anomaly. And next, let's see the components of this library, anomaly. So basically, anomaly has these components, as you can see here in this image. First is the component of algorithms. Those are the ready-to-use state-of-the-art algorithms that don't require defect training data or labeling. How it can do that, we will cover it later. And besides the algorithms, we have the modules. Anomaly has different modules for managing dataset, pre-processing, managing models, post-processing, and deployment. Those modules can be used by a Python API to design custom algorithms for specific use cases, which means you can use those as building blocks to build models or suit everything for your own applications. And besides the modules, we also provide you tools, which are the command line interface-based tools. Those consist in configurable entry points for training, testing, inference, hyperparameter optimization, logging, and benchmarking. And finally, you can see there is deployment. Actually, deployment is part of the modules, but I wanted to make emphasis in that because anomaly has the possibility to deploy using different frameworks such as Torch, Onyx, Gradule, and OpenVINO. Well, then after showing you a very general picture of the components of anomaly, now let's talk about the algorithms in anomaly a bit more in detail. As you can see here, as of today, anomaly has 13 state-of-the-art anomaly detection algorithms that could be classified in 4 main categories. The first category, as shown here, is the knowledge-based models. Those are the teacher-student models, such as FTFPM and reverse distillation models. And the second category is the clustering models. Those usually extract CNN, convolutional neural network features via a backbone, which are followed by conventional methods such as random sampling, k-means, or k-nearest neighbors. The third category refers to the reconstruction-based models. Those kind of models employ encoder-decoder-based model structures to capture the distribution of the normality model, such as autoencoders, anomaly, and dream. And the fourth category is the probabilistic models. Those models utilize normalizing flows to estimate the likelihood of the distribution of the normality. And depending on the use cases, you could use the algorithm according to your choice. You can select models based on training speed, on inference speed, on memory usage, or CPU trainability. If you ask me, for my preference, I don't want to create any bias here, but in my case, with the cubes situation, I use the Padim model, which is one of the clustering-based model. I didn't use a GPU for training, and the performance was quite good. For my first model, I just need to use 10 normal images for training and just 3 images with defects for validation. And that's all needed for training such a cube detection model with anomaly. Okay, that's the introduction for algorithms. But of course, we have other components of an anomaly, such as modules and tools. Well, then here for modules and tools, first we have data. The library provides dataset adapters for a growing number of public benchmark datasets, both from image and video domains. Besides the data, we also provide you pre-processing modules. The pre-processing modules consists of applying transformations to the input images before training and optionally dividing the images into non-overlapping tiles. Here, let's see this example. We know it is common that in real-world datasets, the images are normally high resolution and the abnormalities are very small, which would be challenging for the deep learning model to handle. So to address this issue, Anomaly can tile these large images into patches to support high resolution image training. So that means the details for the abnormalities will not be lost during resizing. So as shown here, we can use this kind of command lines to use the tiler object tiles the image into patches, and which can keep the defect region not resized to keep the details. And after the pre-processing, you can see we have the models as the modules. And Anomaly contains a selection of the state-of-the-art anomaly detection or localization algorithms, as just mentioned. And also, we offer a set of modular components. For the components, you can see here we have such as feature extraction, dimensionality reduction, such kind of components. So those modular components can serve as building blocks. So for you to choose, if you don't want to use the ready-to-use state-of-the-art algorithms we provide, you can use those components to compose your own structure of anomaly detection models according to your own application use case. And after that, we have post-processing module. And Anomaly offers this a number of post-processing features for normalization, thresholding, and visualizing the final outputs. So here, as an example, you can see in Anomaly, there are fully configurable visualization tools. So we can show and we can also save the predicted anomaly heat maps and segmentation masks. And you can find all this information in the predicted results. And after that, we have the module of deploy. As mentioned before, Anomaly has several deployment options using such as PyTorch, Onyx, OpenVINO, depending on the accelerate needs. And also we offer you a set of tools. Those refer to the entry points for training, testing, interfering, benchmarking, or hyperparameter optimization that all makes this library quite easy to use. And finally, of course, this library is constantly tested by unit integration and regression tests to capture the any defects. Well, here we can show you with this end-to-end flow with anomaly. This is the overall flow for this library. And you can see from this figure here, it actually contains 4 main steps. As we shown here, you can see those main steps refer to training, testing, optimization, which is optional, and deployment. That means for inference with deep learning models. So first, let's take a look at training. The training stage only use normal images. So remember that only use normal images, you can do the training for anomaly. And we can train using this one selected unsupervised anomaly detection model. And of course, after that, we need to do validation or testing. This testing stage takes into account both normal images and abnormal images. It performs adaptive thresholding based on the validation set by computing F1 score based on various thresholds, adaptive thresholds. And then the next step is optimization. Optimization stage is so important. With this optimization, we can improve the performance of the models, and we can compress the model size and use less memory. Well, the final stage is the deployment stage. Deployment stage provides number of inference scripts to perform the inference on either PyTorch, ONNX, OpenVINO, or Gradue. And then let's take a deep look for training. So for training, we will use the config manager, as you see here on this image, to set up different modules that will serve as input to the trainer. We can modify directly the configuration file, or we can set up the values using the API. We need to configure the dataset module, set up the format of the data, and also choose the computer vision tasks we need to perform for this training. For example, it could be segmentation, it could be classification. And in the model module, we can select the algorithm, the backbone, and the normalizations. And also we could also manage the metrics we want to select to image level or pixel level, depending on the computer vision tasks we select. And also we could select the threshold options and also the optimization option. So with those inputs, we set up the trainer. You could start doing your training using anomaly. And after that, after you have trained the model, we can run the validation. We could run the validation test in this case using not just the normal data, but also, as we just mentioned, the abnormal data. The anomaly loads this model back to the trainer, and then we can check the performance of the model. And finally, as just described in the end-to-end overall workflow, is the deployment stage. And in the deployment part, we could use multiple frameworks, such as Torch, ONNX, Gradue, and OpenVINO. And I want to explain how OpenVINO is working here. I'm not sure if all of you have been very familiar with OpenVINO, so please give me 1 minute to explain what OpenVINO is. And so you can see here, OpenVINO is actually an open source toolkit to facilitate the optimization of deep learning models from trained from different deep learning frameworks. So those are very commonly used frameworks such as PyTorch, TensorFlow, or ONNX. And so OpenVINO could optimize all those deep learning models trained from different frameworks and also accelerate the inference and deployment using OpenVINO runtime onto Intel hardwares. So what we do using OpenVINO is first to optimize, convert those deep learning models from different frameworks and convert to OpenVINO intermediate representation files. And that is to optimize and then accelerate the inference and deployment on different Intel hardwares. And also OpenVINO could be run on any OS, such as Windows, Linux, Macs, all supported. And also I should say that Anomaly is also part of the OpenVINO ecosystem. Well, now let's come back to the anomaly deployment part. So in the config file, we can set up a simple optimization using the model optimizer. This will change the precision of the model from FP32 to FP16. If you would like to quantize the model, you could also use another tool which we call NNCF, Neural Network Compression Framework. This will help you to quantize your models to int8 model with minimum accuracy drop. Okay, that's some general introduction for anomaly. Now let's take a further look to how can we start to use anomaly. Actually, how to get started using anomalies requires several simple steps. Let's take a look here. What do you do? What do you need to do? First is to create a virtual environment to run anomaly. In this case, we can use this command line to set up a virtual environment for anomaly, which we can call it anomaly env. And for the second step, we can clone the anomaly repository and install it locally with also OpenVINO installed. And you can see those four command lines will help you to clone the repository and install everything within anomaly and also OpenVINO. Then for the third step is to install Jupyter notebooks and iPad widgets using those command lines. Because in anomaly, to get you start with anomaly very soon, we provide you simple and easy to run tutorials in Jupyter Notebook format. So if you install Jupyter Notebooks and iPad widgets, we could start running all the notebooks to learn how to use anomaly very quickly. And I will show you very soon. And so after the first three steps, we could start using anomaly notebook 001 to get started to using anomaly. But before you hit the button for run all the cells in the notebooks, I should remind you, don't forget to download a MV-Tech dataset. MV-Tech dataset is an open source dataset to provide us images for industry anomaly detection images, and it could contain several different categories of data set. It is open source, so you first need to do some registration and you can download the data set for free. And here I'm showing you an example of what's included in this MV-Tech data set. You can see here is an image of a bottle from the bottle category inside MV-Tech. This is the original image. And here we can see there's some anomaly part within this image. And here it also provided the ground truth of a mask for this abnormality area. So we can use this data set to train and to test anomaly for segmentation of abnormality. Okay, how to do that? Let me change my screen and we can start by running a notebook from anomaly together. Give me 1 minute. Okay, let's switch to our anomaly notebook. So these are the 001 getting started Jupyter notebook for showing a quick and simple example to using anomaly to train a data set, to validate and to test the result of using anomaly. And you can you will find this notebook under the folder of notebooks within anomaly repository. Here you can see we have different sections for anomaly getting started. First is the installation, and then we will do some essential import for dependencies, and then we will start showing you the model, the configuration, the training, validation, and some test results. So let me start running all code cells, and while it it is running, I will explain the code, what did it mean to you. So you can see here, this is the whole notebook for getting started to use Anomaly as an example. For me, I've already installed Anomaly in my machine, so I will skip the first two steps. Before running the whole thing, of course, the first thing we need to do is to import the essential Python dependencies. And from here, you can see most of the dependencies refers to Anomaly and some PyTorch lightning, which we use it for training. Here, it also listed the 13 anomaly detection models available in Anomaly. You can choose one according to your own application use case. And in this tutorial, we'll be using Padim as our training model. And now let's take a look at how the codes are working from training to testing. And first, here I want to show you the very important step to begin using Anomaly, that is to set the configuration file. To set the configuration file, we need to define some very important parameters for the training. So of course, we will need to select the model we need to use for the training. And also, we will assign the path for store the configuration file. And here, for your reference, I will also print out all the things included in this configuration file so we can easily understand what has been included in this important configuration file. So in configuration file, you can see we define some important parameters such as data sets for training. In this example, we use MV-tech, and this is the path for store the data set. And the category within MV-tech, we choose the bottle. And the task we show here is the segmentation. And also we can define the batch size for training and evaluation. Then that is the main, and also the split ratio between the data set. And so that is the main parameters we define for data set. And also we can define the models information for training that is also included here. And we can choose, you can see normalization with different options. For the metrics of training, we can use, we can choose image or pixel. So in this case, since we're doing a segmentation task, we will choose the pixel level metrics of F1 score and AURC. And also for the threshold, we will use adaptive threshold. Of course, you could also manually set it according to your own use case. And for the visualization part, we will show images you will see very soon, and we will save all those images in the results. And also that also printed out some essential parameters regarding our training, optimization, and etc. And so we have defined this very important configuration file for us to start training in Anomaly. Then let's move on to see what the data set we're going to use for Anomaly. And you can see here we will use MV-tech as just mentioned. Here it includes several categories, and we will choose bottle as our category. And here you can see this is the original image, and this is the ground truth. After all these have been defined, we can prepare model and callbacks. And here, this trainer showing the training has been started. And during my illustration of explaining the code to you, you can see actually the training has been completed. So the training only uses the CPU on my machine, and the training really takes very short time. It only takes you 30 seconds to finish all the training. And you can see we also printed out some information during the training. And after the training, of course, we will do the validation and see, and you can see the validation will give us some test metric during the validation. And of course, you can see here the pixel AURC and pixel F1 score is also listed here with just 30 seconds for training. And finally, we just mentioned after training, testing, validation, we will move on to the deployment stage. For deployment, we will use OpenVINO to deploy our model to different hardware platforms. And here we will use OpenVINO for inference. So first you can see the model has been output or exported to OpenVINO format. So that is the bin file, binary file for model as exported to OpenVINO IR formats. And also by running this function, we can load the model and perform inference with our test image just loaded. And so we can perform the inference here. And we can also visualize inference results. As just mentioned, Anomaly provides you a set of post-processing tools, which you can visualize the inference results from different angles. Here are the heat maps. And also here is the segmented mask. And also here listed the segmented results here. So you can observe, visualize the segmentation results with Anomaly from different perspectives. It is so easy to use. Okay, so this is the live code running. I'm just showing with you by running Anomaly. And so let's get back to our deck. I will continue to show a bit more about Anomaly. So as you can see, to get started by using Anomaly is actually very easy. You can just by follow the steps of our notebooks from 001, you can start experiencing how to use Anomaly to do from training to deployment on open source dataset. Of course, you can try your own custom dataset using Anomaly. Just doing the changing some parameters in the configuration file, which I showed, I printed out the results at the beginning of the notebook. Just changing the parameters configurations there, you can start training your own custom data using Anomaly. And this is just the result I show you. So you can see this is actually very simple. That I could use only 10 normal images to train such a model to detect the cubes with Anomaly. Okay, so that is the Anomaly notebook. Actually, if you're interested in using OpenVINO notebook, using OpenVINO toolkit, we also provide you a set of OpenVINO notebooks for you to try different deep learning models by using OpenVINO toolkit. And actually, we have provided you over 60 demos within our OpenVINO notebooks repository. And here it actually includes a lot of very interesting demos, which you can try running by yourself. For example, you can try with your own webcam to do this object detection, and also to use your own webcam to do pose estimation. And this is Paula doing action recognition. Another teammate is doing style transfer using her webcam. And also this is me, I'm trying to do some text extraction using our OCR demo. And so for the very hot topic on AIGC, generated contents of stable diffusion, we also offer you the notebook. You can just run all the notebooks and input some text prompts. You can use our notebooks also to generate AI painting for you. And for the widely used ULO object detection segmentation models, we also provide you different versions of notebooks on running, such as ULO v5, ULO v8. Okay, that is the main introduction of Anomaly for my session today. And at the end of my introduction, I would invite all of you here to scan this QR code to do the survey for my presentation today. And we will draw 2 winners from those taking the survey, and we will send out to $50 gift cards. Okay, I can see now we have some questions. Now I can answer some questions for now. Will the detection 360-degree or front face detection? I will say that for anomaly, we are focusing on the using the anomaly for detecting mainly. You can see here the to detect anomalies in manufacturing. In a lot of cases, yes, that could do. So we are previously mainly focusing on those industry cases or the object detection on the not on the face part. I should say that. So you can try that with your own data. I would not. I would encourage you to try it with your own data. Anyway, using your own data to put it in the right folder to change some parameters in the configuration file, you could try to train a model to detect that for your own use. That is very convenient. I would encourage you to do that. And also, which detector does anomaly uses? ULO, I'm wondering how to train it. And so, as just mentioned, anomaly actually uses unsupervised anomaly detection algorithms. So you don't need to, label the anomaly data, abnormal data in the training data set and do supervised training as usual. But in anomaly, you can only use your perfect samples, good samples to train in anomaly. And we have provided 13 anomaly algorithms in that. So you can choose the 30 models from that to do training in anomaly. Is OpenVINO similar to OpenCV? I would say it is also, it has some similarity, but it is different. OpenVINO actually is a framework you can see to focusing on optimization and deployment acceleration. So it is focusing on first optimizing your deep learning models and then to accelerating and deploying your deep learning models onto different hardware platforms. So you can treat OpenVINO as an open source deployment AI framework or toolkit. And so does OpenVINO support training and inference on CUDA? I would say OpenVINO, for now, OpenVINO focuses on the inference side. And also OpenVINO supports the inference on Intel hardware and also on ARM CPUs for now. Is it possible to fine-tune the model to detect different level of anomalies? Yes, I think it's possible. And you can see there are some parameters we listed in the config file. You can you can use that to fine-tune during the training, I think. Are we able to deploy to tablet or to mobile device? Yes. As mentioned, OpenVINO will launch a new version, and also we have community support, which has support OpenVINO to deploy to ARM-based devices. So you could deploy it to mobile devices as well, to Android devices as well. For anomaly detection, must the training and testing images under the same camera angle and lighting conditions? No, I don't think so. If you look at the MVTech open source data set, I don't think all the images are in the same lighting angle. So that could be different. Okay, I think that's all the questions I have answered. And thank you for your questions and to attending this session today.